Uh, Thanks for joining today, and my pleasure to have you all here. We have Professor Arghya Das from University of Wisconsin and Daniel Casali from IBM to share their experiences on big data, AI, and cloud. We also have our special guest, Mr. Dharmesh, as a panelist from Tech Data India. And today's session will be recorded and shared. Q&A, the question and answers, will be at the end of the first and second presentations. You can raise your hands as well as you can post questions in the chat window for the question and answers. And I welcome Professor Arghya Das as a presenter today, first presenter. And he's an assistant professor of computer science at University of Wisconsin-Platteville, USA. Dr. Das research focuses on scalable and efficient analysis of scientific big data, example, genomics, metagenomics, and healthcare data. It also includes both development and large-scale software frameworks and proposing new hardware architecture for efficient data analysis. And one more thing is, to add on, in his experience as well as the last 2 months, he has been supporting our webinar series as a panelist and also as a co-presenter. And also he has been supporting, tremendously on that. And I'd like to extend my, thanks and support, whatever he has been provided. Dr. Arghya, please go ahead and start your presentation.
Okay, thanks Ganesan for the nice introduction, and thanks for giving me the opportunity to present here. So first of all, is my screen visible?
Yes.
Yes, it is.
All right, sure. Thanks. So, good morning and good evening, everyone. I am Arghya Das, and I am an assistant professor at University of Wisconsin-Platteville. Regarding my university, it's in the Midwest region of United States, and it's in the Midwest rural Wisconsin. So we have almost 6,000 folks, 6,000 undergrad population in our university, and I mostly teach them the programming. And recently I started teaching all the projects, including cloud computing and big data related projects also. So anyway, first of all, thanks for joining. Now, in today's presentation, I will basically discuss about the educational side of big data and AI. And the title of the presentation is Big Data and AI Education, and a collaborative approach for online learning, where I will mostly focus on the current state of the online learning of big data and AI education, including the high performance computing. So today's presentation is mainly divided into 6 different parts. First, I will define some terminologies like big data, AI, online education, and all these things. What are they? And then I will discuss all the issues and challenges in the educational side of big data. And then I will discuss how to address all these issues and challenges and provide a collaborative solution. And then I will give a brief demo of a website that I have built and how we can address all those challenges. And after that, I will show you some use cases that we are doing through this website that we started doing already. And then I will conclude my presentation, and we will discuss about the participation opportunity and all these things. So to start with, first, let's say, what is big data? So big data is basically can be divided, can be explained with the 5 V's. That is volume, velocity, veracity, value, and variety. Well, before going to all these things, I will try to keep my presentation as border level as possible, because I know that in these presentations many undergrad folks joined, and many students populations are also very high. So I will try to keep them so that everyone can understand, and everyone can understand all these things that I will explain. And yeah, so well, this is big data. Big data can be defined as 5 different 5 V's, that is volume, velocity, variety, veracity, and value. And now, to handle all these different 5 V's, so there are 3 different types of programming models have been proposed. And if we look back, then we will see those 3 models are MapReduce, graph processing, that is vertex-centric graph processing model, and distributed NoSQL model. On the other hand, if we divide the analysis types of this big data, then we can see that there are 3 different types of analysis, like batch analysis, interactive query analysis, and streaming analysis. And finally, if we see that if we divide the hardware at the border level, we can see the 4 different types of hardware. Now, those hardwares are, if we see from the computational side, those hardwares are disk-based computation, in-memory computation, CPU-based computation, and GPU-based computation. Now, for every different types of combinations of programming models, analysis types, and hardware types, every day different types of technologies are being proposed. For example, what is the meaning of these each different combination? So for example, if we see that MapReduce for batch analysis on a disk-based environment, that's nothing but our Hadoop, where the revolution started, the revolution for the big data started. Then if we go for this NoSQL, then batch analysis, and if it is disk-based, then there are lots of examples, let's say HBase, MongoDB, and all these things. If we go for NoSQL, interactive query or batch analysis, and then in memory, then we will see there is Hazelcast, there is Redis, lots of different things. And nowadays, there are lots of GPU-based computation is also adding. For example, like cuDF and all those different types of frameworks are coming into picture. So for each different types of combination, there are a technology is being proposed. So every day a new technology is being proposed. So how to keep up with this technology in an educational environment? Next, not only big data, artificial intelligence is another major focus of current computation. So there we can see like there are lots of things like machine learning, deep learning, statistical machine learning, transfer learning, and so on. And if you focus on any of these fields, you will see that there are lots of different technologies are being proposed. For example, like deep learning has TensorFlow, PyTorch, Caffe, all these different things. Statistical learning, if you start thinking about it, you will see that there is Bayesian analysis, there is hidden Markov model, Markovian chain, lots of different things. Transfer learning is relatively newer, where actually you are taking the learning from one data set and you are applying it to another dataset based on the similarity. There are other different types of machine learning also. For example, perceptron, for example, a Bayesian network, and all those things. So here also we can see a lots of different technologies. And on the finally, if we look at the hardware part, we will see that there is also a revolution happen. So this is the high performance computing hardware, have like 2 different way we can divide it. So the first one is the structural component of a high performance computing, that is the CPU speed, GPU flops, IO performance, memory management, network bandwidth, and all these things. And on the other hand, the overall cluster architecture. That is, how should the cluster look like? Is it a supercomputing cluster, or is it a cloud-based architecture, or commodity cluster, or scale up versus scale out, hyperscale system, or what it is? So, and based on these hardware infrastructure, the software infrastructure that are being proposed, they have different types of performance implication. And not only performance implication, there are performance to price implication also. So in a traditional education system, how can we incorporate all these things? So the bottom line is technology is changing at a very fast rate. So how to keep up with the education? So now let's look at the current mode of education. So we can see that there are two different modes of education. The first one is, of course, the offline education, where which is basically synchronous and face-to-face learning, which is great for student engagement in big data and considering this different types of programming, nitty-gritty programming and all these things. But honestly, but this type of settings normally respond slow with the technology changes, because it greatly depends on the personal interest of the instructor, then limited collaboration opportunities based on the geographical location and everything. For example, you are situated in a very remote area of the country where the industry is not grown up and your educational environment is there. So you won't get much collaborative opportunity. And also there are other staffing and admin issue from the university. So because of all these things, this offline system, although it is great for student engagement, normally do not respond quite good for these technology changes, especially in this data science and AI domain, big data and AI domain, where technology is changing basically every day. So of course, online mode is one solution, which where there is no boundary between the intellectual thought sharing. So the mode of learning is totally asynchronous, and it does not depend on the geographical location of the education or the students. But if we analyze the current online educational market, we will see that retention rate is extremely low. And I have analyzed that these educational retention, the lower retention rate is because of few different reasons. For example, the materials are really lecture heavy and less proactive learning. And also there is a skepticism about the ability to apply the skills learned, because most of the time you will learn from the video lecture and then you won't get much of the practical hands-on scenario, and you are always skeptic that how will all this work. Now also there is a problem of lower return on investment. Although online education system was built to democratize this data education, but because of the high rate, high payment rate and all these things, so it basically didn't work quite good. And according to many reports from the federal government of USA, that online education system did not serve the purpose that they wanted to, that they were supposed to do. So there was something called hybrid learning also, but basically in the current scenario, hybrid means offline courses upload materials online so that everyone can see that at later point of time, or if it is an online course, the host actually, the instructor actually have some live video conferencing, or there is some live assignment grading and all these things. But is this hybrid setup enough for a big data and AI education? So the bottom line is, whatever it is, whether it is hybrid, whether instructor is getting face-to-face or whatever it is, the major question remains how to evolve with the technology changes. And the other thing is how to bring the high performance computing infrastructure in the education. That's a very important part. So for example, all the educational institute may not have access to a supercomputer because they are costly. Now, all the educational institute may not have a good cloud infrastructure, may not have their own data center, may not have their uh, access to the supercomputer or any other HPC system, may not have the industry collaboration at some collaboration. So how can we spread the big data and AI education across the globe? So that's one of the major focus of this research, what I am doing and what I am doing with OpenPOWER together. So so let's move on to the next slide. So as we know the current, as we have just learned the current state of data science education, so let's see what are the issues and challenges exactly. So if we just look at very carefully on the current online and offline teaching, we will see that there are two major challenges in the current, two major issues and challenges in the online data science or high performance computing or AI courses. The first one is course structure, asynchronous arrangement of lecture and hands-on. What does that mean? That means you will be given a video interface that where you will learn the content, but your hands-on assignment you have to rely for later stage. Some online platform actually offers the infrastructure also with some of the open source platform like Google Colab and everything. But again, it entirely, the setup is entirely asynchronous. You will get the video lecture at some point of time, and then after some point of time, if you think that you want to do some hands-on, then you can do it. And most of the time what happens after this lecture heavy materials, the students just lose the interest, and they just do not do the hands-on assignment and or the hands-on practices, and the learning outcomes is of course not very good. So the basic problem is there are very few active learning component. When they are getting the lecture, they are not doing the hands-on. So that's one of the big problem. And the other problem is of course the course infrastructure. So nowadays course infrastructure in online or offline environment means there is a virtual lab experience without the knowledge of the underlying hardware. For example, you will be given an account and you will run the code and you will get access to many different software and you will just run everything that are required for your code. And now the UI experience also does not feel real world most of the time. So for example, sometimes you will see some online educational platform where you can write the code on the directly on the web browser in some kind of like, let's say some kind of simulated environment. They will just provide some web prompt for Python, and then you can run a few small code, small trivial code there. But that thing is actually does not give a feel of the real world environment, neither the development environment nor the production environment. Just writing the code on the browser, according to my experience, it does not work pretty well for the student who are learning coding, learning programming. So as a result, what happens is the learning outcomes are very poor. So learning at start, students, so far the materials are easy to understand, the learning outcomes are good, but in the end, it started getting poor. And at the same time, the retention rate also start diminishing. So in the beginning, so most of the time you will see there are several statistics available over internet and as well as in many research papers that in most of the online courses, many students actually deposit their fees, but hardly they finish the course. So these are some of the reasons. So lack of engagement, because the infrastructure in UI and everything, structure, infrastructure, UI, everything is designed in such a way so that the engagement is less. So what can we do? Of course, collaboration is one of the way. Only one single institution or someone cannot do everything. So collaborative solution is required. And here by saying collaborative, what I am saying is a unified learning solution or ecosystem which can improve the collaboration over time. It's not like just collaborating with one single company or one single other professor or in some better university just for one product or just for one system, just for one course. It is a unified learning solution. What does that mean? That we are going to discuss in this video. And here, collaborative solution, it works, it is beneficial not only for the educational institute, but also very much beneficial for the industry also. Because nowadays, actually in industry, if we look at the statistics of online education, we will see more than 50% of the student, 50% of the student in the online environment are coming from industry, because they get lots of new projects. They need to keep up to date, go up to date and everything. So they also get benefit from this collaborative solution. So let's see, how can we complete this entire cycle? So here the idea is, first, there will be a learning solution for different type of software and middleware, which will be packaged with different type of container and which are optimized for different hardware. So this is the entire ecosystem of the learning solution. So far, all the online environment or offline environment in learning, in the business of education, they actually complete the cycle right after this software or middleware. They really do not go beyond. They really do not look at this packaged with container, or they really do not look at the optimization with hardware. So they just complete the circle from software to, again, they go for the collaborative solution. So they just break the cycle here. But so here, what we are proposing is a complete cycle. So the learning solution that I am proposing here is basically starts from a beginner's level and go for the intermediate level and then an advanced level. And of course, there should be some professional touch also, professional field also. So in the 100 level or the beginner's level, I have just named it as basic, where we are just going over where the students will learn about inception and history, how the data came, how the data and AI educational history, components, building blocks, applications, and everything. And then in 200 or intermediate level, they will start configuring the systems. They will learn more about the theoretical basics and architectural details, installation, and then based on the architectural details and theoretical basics, they will start configuring the software, and then they will start coding on the server, and of course understand the impact of configuration, parameter configuration and parameters tuning and everything. So that is about the intermediate level. And then advanced level comes with the optimization. Now, if we can provide this type of learning solution to the student, then it is a complete learning. So that, and of course, there should be some kind of professional things also, and professional, by saying professional, what I am saying here is project-based learning. For example, everyone is not looking for an undergraduate level teaching undergraduate level education, but many folks, many students actually join to get some idea of their next project, for example, in the industry, how to do that. So for those students, actually there should be some professional component in the learning solution also, as we are talking about the entire learning ecosystem and not only one single course or on one single product. So this is the learning solution. The first step of the ecosystem, the top layer of the ecosystem. Then let's see what do we have in the software or middleware. So software and middleware, we will learn about the programming. So here actually in programming means in big data and AI domain, these 4 languages are actually becoming very, very, very popular nowadays. So one is Python, R, Java, C++, and JavaScript. If someone can master all these, someone can master all these 5 different languages, then they can do better, they can get better job and they can get better understanding of big data field. Then there is Hadoop stack. So here actually why I have put Hadoop stack and big data stack, because that I will come later. But anyway, so Hadoop big data stack is the first big data stack that have been proposed, and this is the open source counterpart. So if we look at the big data side of big data history, we will see that some papers have been published from Google, for example, MapReduce, Bigtable, for example, Pregale. All the different papers have been published from Google, and Apache came with their open source counterpart. So Hadoop big data is one of the fundamental things that data science students should learn about the big data when they are learning about the big data or AI related stuff. So not only Hadoop, here you have to learn about the AI stack also. Now, now in the entire, if we analyze the entire education domain, we really do not find any AI stack as such. But thanks to IBM and thanks to OpenPOWER, that they have generated small package for called Power AI, where actually you will get all the different types of AI related software all together in one single package, so that you will get a brief idea, brief idea that what is going on in the entire AI domain. So, so this is kind of, so if you want to do like get a better knowledge for all these different big data and AI related things, you should go over all these different software. These are the programming things, these are the Hadoop related things, and then these are the AI related software. So in Hadoop there, so let me just go into the details of these things a little bit. So if we go over the AI stack, we will see that Caffe, there is Theano, there is TensorFlow, there is PyTorch, there is Chainer, and all these things. If we go over the Hadoop stack, most important things are like HDFS, then Hadoop, then Yearn, then Hive, Pig, Storm, Spark, HBase, MongoDB. These are the most important things that you need to learn to be in the competition. So now let's move towards the next part. So how can we bring all these things together? We can bring all these things together by means of packaging. So packaging means nowadays actually there is a revolution happened after the invention of after the introduction of Docker. So the way we are actually trying to educate the students are like we will package all the software inside a Docker container or Anaconda or OpenShift, and then we will ship the entire thing in the optimized in the hardware environment. So for example, if you want to get like, if you want to deal with, get some knowledge about TensorFlow, we'll just package everything so in Docker, and then just by firing single command and everything, you can get access to an optimized environment of TensorFlow. And so if we just see details, so there we are planning to maintain a learning repository. So they, in an ideal case, there should be a learning repository where all the hardware optimized images should be kept, and then the students can install the optimized images according to their need. So here the students and undergraduate students can install the image on the local host, that is on his or her laptop. An industry person may have to check with different hardware system for performance and performance analysis and everything. Or the industry person may want to install the software on a server environment where he or she has access to, and then start learning on that server environment, which is basically real time, which basically makes more sense for his or her own work. And also it can be, let's say, a PhD student. They can also install the image from the hub, and then let's say if someone is working on the supercomputing or HPC research, the PhD student can install the image on the supercomputer of that student's choice. So that should be an ideal environment where there will be lots of virtual images in one one hub, and then from the student, then from there, all the students should be able to copy those hubs, copy those images, and make use of it for better learning outcomes. So here the solution that I will propose, we are using actually the Docker containers, and we are also working on OpenShift, but that is work in progress right now. So anyway, by means of, so the motivation of this containerization is basically better learning experience. So prepare the optimized container for different hardware infrastructure, give the student a facility for painless integration of the actual deep learning or AI or big data environment to the real-time production type infrastructure. So that's the major thing. And finally, the last part, those containers are basically should be optimized based on the hardware infrastructure. For example, there may be many different type of hardware. There may be Power 9 hardware, which contributes towards the world's fastest supercomputer, that is Summit. There may be NVIDIA GPU, many different type of GPU. There is Tesla, there is Pascal, there are Volta, lots of different things. And there are Amazon AWS cloud platform. They are using many different type of hardware infrastructure. That can be Intel, that can be AMD. So there are lots of different hardware infrastructure are there. And what the unified learning solution should have the provision for all different type of images, optimized for all different type of containerized images, optimized for all these different type of hardware system. For example, optimized TensorFlow images for IBM Power 9, or optimized TensorFlow images for Power Cloud, or optimized, let's say, optimized Hadoop for OpenPOWER partners system like Raptor or Xilinx, or let's say some IBM Caffe, or some GPU optimized data frame like QDF or something like that, QDF optimized for NVIDIA Volta, something like that. So these type of solutions are required. And not only this processor technology, but these technologies should take care of the storage medium also, like SSD or hard disk drive and everything, because they also have the different impact on performance, and the students should know about all these things to get better learning experience. So here the major motivation of this unified learning solution is to give the student a facility to learn with the hardware of their own choice. As I have told, an undergrad may be interested to learn the software on own laptop. An industry software developer or some project manager may be interested in doing performance analysis on different hardware infrastructure, including AWS, including IBM Cloud, including Power 9 processor or Intel processor. So all these different types of facilities should be there. So that is about that is all about the unified learning solution. So the major motivation of this slide is to let you know that these are all the different components of the learning platform. If we get the learning, if we just analyze the entire learning paradigm, so it is not only about learning solution for software and middleware, but there are like containerization, and there is a big part for hardware learning also, without which the data science education may be incomplete. So those things the learning solution should take care of. So basically, if we can develop this type of collaborative solution, then the use cases are many. And as I have told, use cases are not only for academic institution. Use cases are industry people can also use this type of learning solution. So in academia, students who wants to learn new topic in big data and AI, they can utilize this type of learning solution. Then instructor can refer or use it for better learning outcomes in the course, or researchers looking for better high performance computing infrastructure with optimized software, they can also use this type of learning solution. If we focus on the industry, then we will see that there are many industry person who wants to learn the new topic for a next project. How to do that? Sometimes they get lots of different projects, like a customer has some demand which needs to learn TensorFlow, and not only learning TensorFlow, but the employee also have to propose what type of hardware infrastructure should be acquired or should be procured for better performance, and better performance to price also. So for all these type of different analysis, it is very important to have a unified learning solution which will consider all, like software, container, as well as hardware. So in industry, if the employee get better knowledge about all these different things, TensorFlow on top of Intel, or in TensorFlow on top of IBM Power 9, if the employee get better overview, then only they can provide better consultancy, and the customer satisfaction will be much higher at that point. So here actually, as I will give you two or three different examples where I have worked with many different folks on these type of things. So the first project that I have done with this unified learning platform is like a genomic error correction. Genomic error correction is my research background. I do lots of stuff with the big data genomics, where I handle, like, where I analyze human genome, then some metagenome data set and everything. So those things, through this unified learning solution, what I try to do is I always try to bring many researchers together and then try to utilize different type of hardware infrastructure through this unified learning solution. And because of these things, it was possible to check to do the performance comparison in terms of hardware also. So for example, in a research, we have seen that IBM power system actually performs almost 7.5x times better than an existing Intel-based system. So this research, while doing this research, collaborative resources were contributed by Louisiana State University, Oregon State University, and University of Oregon. So those things are possible through this unified learning solution. I will show you a demo, don't worry. I will show you that how did we do that after a few moments, but these are just for the, just to let you know that these are the use cases where I have already worked. Not only this genomic data analysis, we are also working with big data healthcare data interoperability over blockchain, where actually I am working with Amity University in Kolkata, where actually we have got server from many different locations across the world, and then we are doing some kind of data transfer over this type of server and doing some kind of some analysis. So far we have done this project on AWS, and we are trying to port it to the power system, and we will see if there is any performance implication on this, since we have the unified learning solution. So next one is a movie analysis. So this one is basically a fun project with a few of my students, and those students actually belong to industry. There are a couple from Deloitte, there were a couple from TCS, and there were some from there were one or two from Facebook also. So all of them, I was just mentoring the project, and their major motivation was to learn about 3 different domains of deep learning. So that is image analysis, natural language processing, and time series analysis. So so I have just came up with this type of fun project like movie analysis, where we have just divided the entire movie into lots of different frames, and then we have used some subtitle, we have used the subtitle, and then we have extracted the audio track also using some software, and then did lots of deep learning and deep learning type of analysis to classify the genre. And so here the major motivation of this thing was to compare the performance of different deep learning framework for all these 3 different type of workloads. For example, this image analysis, natural language processing, and time series analysis. And this project for the server was contributed by, a Power9 server was contributed by University of Oregon system. So these are different example use cases which involves all academia, both industry, academia, as well as research. So now let's see a brief demo. So as I was saying that there is a unified learning solution. So how does it look like? Well, we know that there are lots of, there are lots of benefit of this type of unified learning solution, but how will it look like? So how will it look like? So basically it should look something like this. So here actually I am trying to work on a website. So I'm working on a website called institute.academy. So here actually what we are doing. So let me just show you a demo. If you just go to the onstitute.academy. It is the web page. When everything comes together, the solution looks something like this, where you have just need to sign in. So I have created one account for myself, and there are like 10 registers. These 10 registration actually my students who actually got some where I mentored. I just discussed about that movie analytics project, and these 10 registration are from those students. So anyway, so this is a homepage for this unified learning solution. The name of the platform I have given as Onstitute, which stands for Online Institute, where we have lots of different types of solution, lots of different courses we are offering. Of course, this is the first phase. That is the topmost layer. The first thing is the learning solution. So of course, there are big data related course, there are deep learning related course, there are power architecture related course. Since we have focused on the hardware also. So in an online environment also, we are able to give hardware lesson also. And so this is, of course, right now the collaborative partners are UW-Platteville, OpenPOWER Foundation, IBM, and of course there are Oregon. There is so lots of different universities and industries are there already. So but before and now let me show you that how is the learning experience with this type of platform. So let me directly go to this course section where let me select this deep learning. And now in deep learning, let's say I am not going to the lecture and all those details, but let me show you a small demonstration that how will it look like when everything comes together, how will the learning experience will be, and how it can improve the learning outcomes. So for example, let's click on this link where actually you will learn about the first code on TensorFlow. So you can just learn this video. I am just, you can just run this video. I am pausing it because it won't allow me to talk, and just to reduce the noise. And here what I am doing is, here in this window, basically, in this window, what you can do is you can change the infrastructure as well whenever you want. So for example, I have a server, as I was saying that Oregon is contributing a Power 9 resource there. So if I just change it, I will see a Power 9 resource over here. So there actually I can start learning it. So let's say you are seeing the code in here, and you can just directly type the code in this window, TensorFlow as TF. So let's see, yes, TensorFlow is already implemented. So this is basically a Jupyter notebook, and in the back end actually there is a Docker container or which is working on the Oregon server, which is specially optimized for that Power 9 system. And then if we do like hello equals tf dot constant. So if we do like hello TensorFlow, so now let's run it, and then session equals tf dot session. Let's see. Yep. So now if I just print run, and then so here you can, while seeing the video, while watching the video, you can just directly do the hands-on program also. But of course, there is facility to do it in the other window also if you want, that is possible. But it always works better whenever you are watching the video if you try the code in here. So students learn better in this type of setup. As I was saying that the lecture and the hands-on should be synchronous. And then there is and not only that, you can always change the server just by clicking one thing. And so here also you can run your own TensorFlow code. So this is now a server from Intel server at UW-Platteville. Just before that, we have just shown that there is a Oregon Power 9 server. Also, what you can do is I have a local host machine running, which is Docker. So you can type in here also. So let's do like HTTP localhost 80. If we just do this, then you can change it to localhost, and here you can learn Python 3, and then you can type your code. And not only this, you can always go to the terminal also, since it is Jupyter Notebook. Let's go to that Intel server, and you can always go to the terminal. And if you want to run your code, if you want to run your bash script or anything, or any Python code or Java code, or whatever you want to learn, whatever you want to run, you can run it in here. So all the softwares are installed. All the softwares are coming from the Docker container, and you can just by one click, you can change the server. You can do the performance analysis on different type of infrastructure. And if you want to get the setup information, either you can run your command in the command prompt of Linux, or you can directly click on these. You can directly click this setup. I think the website is a little bit frozen. So let's see. So here actually you will get all the hardware details. What are all the hardware that are provided for the course? So this is a deep learning course, and all the servers are provided by University of Oregon. We are also using AWS micro instance. Also University of Wisconsin-Platteville. All the universities have provided the server, and here you can see all the details. So if you want to contribute with it, then you can always contribute with the server, or here you can see all the links where you can see all the books and everything. And of course, there is a setup button also, where you can just do where you can just see how to set up this environment. So basically, setup means you have to just copy this entire command, this install image, and you have to run it in your local machine or any of the server, and that's it. Whenever you will run this command in your command prompt in Windows, or so you have to have Docker installed on the machine, and whenever you will run this, then your environment is integrated to this Institute's unified learning solution, and from there you can start using anything. So if you want to use the already provided server, you really do not need to install anything from here. But if you want to do your own setup in your server, in the server of your choice, then you have to do this type of setup in here. So that is in a nutshell what a unified solution, unified online solution should look like. So that is about a demo. And then, so if you really want, so these are the future goals. So the collaboratively improve the learning infrastructure of data, AI, and HPC education, irrespective of geographical boundary, and of course, spreading the data and AI education to meet the global demand of quality data expert scientists. So this is the goal of Institute. And if you want to participate in that, then you can contact me directly with all these different type of question, like any data learning question, want to see the course specific on specific topic, if you want to take part in cool projects, outsource or mentor any project, or let's say if you have some cool idea of some project, want to educate the people with your new software tool, if you are a researcher, or want to showcase your new hardware infrastructure, let's say you are a hardware vendor, or you are some third-party hardware provider, you want to showcase some of the new hardware infrastructure, you can contact me, and you can directly integrate your platform to Institute, and then you can reach out to many different people. And then also you can package the learning solution with your new software tool. For example, you just came up with a new very nice software and you want to educate the people, so you can package the entire learning in a containerized environment and you can ship it to Institute. So that is about Institute, and so thanks for listening to this. And here actually I want to let you know that I will officially launch this integrated platform on September 1, tentative though, and there will be at least 10 courses on popular big data and AI framework with hands-on learning support with Docker, Anaconda, and OpenShift. And you will get lots of different cloud platforms and HPC platform provided by OpenPOWER, provided by many different universities together. So thank you, and thanks for joining this webinar, and a big thanks to IBM and OpenPOWER for arranging this webinar and providing the hardware infrastructure support. And of course, a very big thanks for UW-Platteville for supporting my scholarly development activities related to this project. So any question? So that is it from my side, a unified solution for learning, where academia and industry can take part. And that is the website. How will it look like, the actual product? That is it from my side. And so any question?
Thank you, Mr. Arghya, for a very detailed presentation and sharing your experiences about online education platform using Power9 and the other infrastructure, and also sharing the use cases, very nice use cases about big data, AI, and all other features integrated, and this is I think this is extremely very important for students who want to get educated quickly and get on to their next level of job, and whatever the career they can set it up. Really appreciate it. Very good presentation, Professor Arghya. And participants and panelists, any questions for Professor Arghya?
Hi, Ganesan.
Hello, Mr. Dharmesh. Yeah, go ahead, please.
Yeah, a couple of questions for Dr. Arghya. First and foremost, let me really appreciate this initiative that he has taken in the form of Institute Online Learning. A very, very unique perspective that definitely I can think of, and which really seems to be unparalleled in today's world. And the need of the hour, we all know, is basically a collaborative and unified learning, as Dr. Arghya presented today. Excellent presentation, just like what you also acknowledged, Ganesan. I just had a couple of questions in my mind. One was, we obviously are seeing a lot of analytics use cases other than what Dr. Arghya presented, which are around use cases like deep fake analytics, or maybe sentiment analytics through video, through CCTV recordings and things like that, okay, which are becoming very, very important in terms of identifying let's say COVID-19 patients, like probably from a CCTV camera to take their take a video footage of their faces and try to analyze whether that person seems to be sick or not. So is Dr. Arghya, I mean, is Institute online learning kind of also thinking around those courses as well?
Oh, yes, of course. Thanks for this question, Dharmesh, first of all. So as I have told I think that was a very small part of this presentation. I should elaborate bigger. Pardon my ignorance. So as I have told, there is an opportunity of professional courses. So there are 4 different level of courses. First one was beginner, intermediate, and advanced. And then there is a 4th one is professional level. So in that professional level, we always go for the project-based learning. And in project-based learning, where we can actually include all the different types of things that you are saying. For example, right now, I am actually trying to develop one course on Bayesian network to expedite the vaccination process of COVID-19. So these type of courses are, of course, on my list. And we can do that in a collaborative environment. And that's a very big thing that we can do, actually.
Right.
And that's a very nice thing.
Yeah, thank you. Thank you, doctor, for just informing us about that. Okay, the other question that I had in mind was you did mention about the hardware platforms on which the courses are going to be available. Okay, end of the day, probably students who do come on the Institute online learning platform, okay, might have a question that which is probably the recommended platform to use for the courses that would be put up on your portal. Okay, so what do you think? I mean, do you think that IBM Power 9 could be the recommended platform, or what is your view on that?
Well, that's a great question, basically. So that's where actually the existing online platforms lag. They really do not have any hardware infrastructure. So my motivation is let them use all the different types of hardware, design the courses. Let's say, for example, let me explain it with an example. For example, let's say I have designed a genomic analysis course, all right? And then let the user do all the hands-on on both Intel and IBM Power 9 system. And where, what I have actually done, basically, and of course, for this genomic analysis and for many different deep learning analysis, according to my experience, IBM Power 9 has just outpaced Intel-based hardware. I think we have a paper also. When I was doing my PhD, we had published a paper which was accepted in ICD-CS, I think, where we have did a lots of comparison between different types of hardware. And there I have seen that IBM Power 9 with NVLink actually outpaced most of the other platform, Most means, I mean, all the other platform, all the Intel-based platform. So definitely, I think that IBM Power 9 will be a recommended platform at some point of time. But again, that depends on the students. Let them be satisfied first.
True. So thanks, Dr. Arghya, for that. In fact, as Ganeshan introduced at the beginning of this session, that I represent Tech Data, who are probably the largest global distributors for IBM. Okay, based out of US. I am though based in Mumbai right now. And just to give you an example about this performance that you talked about, IBM Power 9, and to all the participants who are there on this session. So thank you for being a part of this session. We actually indeed did an exercise for a comparison on an Intel platform as well as on a Power 9 platform by simulating some AI courses on that. Okay, and probably getting some students or users to access that. And to our pleasant surprise, what we found that a typical Intel platform with say a couple of CPUs and GPUs, okay, and a similar IBM Power 9 platform with a similar configuration. Okay, while the Intel server was able to accommodate only 20 to 30 concurrent students at a time for accessing the different modules, but in case of IBM, it went to nearly 60 to 80 students. Okay, depending on the modules that they were accessing. So this was like indeed an eye opener for us, and we have really taken this story to a lot of colleges and institutions in India. Okay, so for the benefit of the participants here, Tech Data as a distributor, we have invested in a couple of Power9 servers. Okay, and all of you are most welcome to get in touch with Ganeshan or with myself. Okay, and we could really offer you that platform for either demo purposes, or you want to run some workshops around Power AI. Okay, we would be more than willing to help you out on that. So thanks, Dr. Arghya. I think in the interest of time, there are definitely a couple of other questions, but I think in the interest of time, I would
Yeah.
like to limit myself to these questions. And over to you, Ganesh.
Sure, Dharmesh, and also I want to tell you that if you are interested in designing some courses or something to educate the people with Power9, I am open for that. We can work together and we can do that, and we can take it to institute and make it public.
Definitely, Dr. Arghya. I'll keep that in mind.
Thank you, Professor Arghya, and thank you, Dharmesh, for the wonderful discussion. And let's, I also would like to invite Professor Aswani, VIT India, as a panelist, and he has a question too. Maybe we will limit, one more question, and then we will move on to the next session. Professor Aswani, please go ahead.
Yeah, Ganeshan, thank you, Dr. Arghya. It's an excellent presentation. I'm really amazed that you are trying to do some of the good work and to address the issues that the online education at present we are facing. Though there is a big boom about the online education, though there are several couple of platforms, the one what you're presenting, the idea, the concept is really excellent. I just wanted to know that the couple of issues what we have raised in the beginning about the student getting a feel of access to the high performance computing and then playing it with that. I think I'm not sure if is there any dashboard when the student is trying to execute some of the the programs and then select the platform in which he wants to execute, and then whether there is any dashboard that he can really see how actually the performance of that particular backbone is doing it, and then when he selects the another platform and how it is coming out, so that if it will be much more appealing to the student, whether such idea is there. That is what one of my first question. The second question is, I think there is a lot of scope to inculcate the gaming principles in the design of these courses and all. I think there's a big huge potential is there, and I think we can work on that.
Sure. Thanks for the question. So let me answer the first one. Regarding the dashboard, yes, of course, I also know that this is very important from the students' learning perspective and as well as performance analysis perspective, both. But yeah, I mean, I am working on it. But I mean, it may take a little bit of time to do all these, to bring all these things together. So may not be in the first release, may not be in the September 1, but definitely in this fall, the dashboard inclusion should be there, how to do it. So it will be there. And regarding the second thing, and of course, I am very much interested in collaboration. So if you have any type of other ideas of like collaborative courses or student outcomes, how can we make it better? Please feel free to contact me directly and we can work together.
Definitely. Thank you. Thank you.
Mm-hmm. Did I answer all the questions, by the way?
And thanks, Ganesh. It's a wonderful presentation.
Okay, thank you. Thank you, Professor Aswani, and also Professor Arghya for the wonderful presentation. Thanks again. And let's move on to the, Professor Arghya, actually, there are some questions on the window. Probably you can directly go and answer them.
Yeah, I can answer that.
While the second presenter, will be online. I'd like to invite my colleague Daniel Casali to do the presentation, and I just want to say a few words about Daniel's experience. Daniel is a thought leader, a specialist working at the IBM Worldwide Systems Red Hat Synergy team as a technical subject matter expert. Daniel has more than 15 years of experience with enterprise Unix systems and more than 10 years on multi-tenant customer computing, power sharing, before it was called cloud. And he has been working with power system and storage as a lab service consultant. And today his main focus is Kubernetes infrastructure and Red Hat OpenShift. And he's going to be sharing, very wonderful, concept, on cloud and how, what are all the use cases around that. I welcome Daniel to start the presentation. Daniel, please go ahead.
Hello. Thank you, Ganesan, for the introduction. Can you hear me well?
Yes. Yes, Daniel.
Great. Thank you. Let me try to share a screen. Can you see my screen correctly?
Yes, yes, Daniel. Yes, Daniel.
Let me give you full. So the idea here is to show a little bit of the infrastructure that we have to provide customers to build solutions like the solution Professor Das presented before me. This is to show how we can enable everybody to build a hybrid multi-cloud and use the solutions either on their own data center or any kind of cloud that they want. But first is the definition of what is cloud and what is a hybrid multi-cloud. And so first I would like to define cloud for myself and to try to bring everybody together to what I think about cloud. I don't see cloud as a place or an environment. And I tell that because I have accounts on multiple clouds, and I see the all of the clouds has the same behaviors. For example, cloud number one, this is cloud. It's IBM Cloud. I have a personal account there. And you can see that it's really about having something to offer as a service, all of the offerings that you have organized in a search bar for you to be able to deploy the services that you want. And for example, this could even be a learning platform. Like, so you could have a button here that would be a learning platform. Again, on another cloud, all of the offerings that they have in the search bar. On a third cloud, again, you see the same pattern. The offerings that are available to the users of the cloud in the search bar. And this is OpenShift that was mentioned on the previous presentation too. And I will get a little bit more on why that and how can be used to create offerings to your internal users with the offerings in the search bar to show all of the offerings that the users of the platform will be able to. That brings me to the idea that cloud is an experience. It's the experience of ease of use of a platform, deploying applications that will be used by the end user ultimately. That's really what is the cloud about. So after we understand the cloud experience, let's try to define what is hybrid multi-cloud. I see the hybrid multi-cloud as a computing environment combining the clouds that can be created on-prem. Like I showed, OpenShift is one of the ways of creating that capability or that experience on premise and on the public cloud, allowing that students, for example, from one university would have capabilities of choosing their own products that are offered. So for example, if we are using some tools for math, like a math lab, it could be done and could be provided in this case in a cloud environment based on containers. And what is the multi-cloud? Multi-cloud is the idea of using many different cloud providers for the infrastructure part of your cloud. So then we get to the hybrid multi-cloud idea. That is the combination of both of them, having cloud in a private way on your own data center and many other clouds. And this can also be a multi-architecture, because we do have many types of architecture out there. On many clouds, we do have x86 and Power being offered as architectures. We also have even ARM being offered as a possibility of computer architecture to use the cloud on. So that can be also the hybrid use case of multi-architecture. It is already being done by many of the customers in industry already, and in academy too. So they do have private clouds, and they do use dedicated clouds on public service providers. And that's being normally managed by the traditional IT. And the movement between the clouds will be happening for sure. The public cloud is very good if we want to provide point-in-time services, deployments, if we want to try to develop a new workload. But the TCO of a cloud for many years for a given product is normally expensive compared to what you can do on-prem if you are really maintaining an application for a long time. So why we would do that? It's always normally about cost and return of that investment. So people will use public cloud still for this use case where it's really important for them to have agility and create a fast environment for development and delivery of products. But most of these workloads, after they are done and ready for production, they will probably come back to do production workload on data centers that are secure, that has a compliance to regulatory things, and that will be mainly what we will aim for. Any questions up to now? Because we are entering on how to do it now. Okay, so how this will work. We have the monolithic applications that are the traditional workloads. They are heavy, they're hard to maintain, because if you want to change a code, you probably have to recompile the whole code. And the cloud-enabled applications will start accessing these old applications on the first time. So we'll have data coming back and forth from applications that will be using a backend. So Tuesday? Still. but are already container based, like we saw. And then after a while, we will have native apps that are all containerized. Even the data plane of it will be done on containers. And this is probably the future of most of applications. Just because it's cheaper to produce software that way, maintain and deliver to the customers. That's what people call the continuous integration and delivery, and in trying to give your product faster to the market.
Yeah, and I'll work on the materials and the content.
That's the evolving integration and deployment that we would have in a data center. And that's just because it's easier to use this in a hybrid cloud. All the libraries and binaries that your application needs are already integrated within the container. So I could migrate an application from one platform to the other without the need to rebuild everything or have complexity that would add from migrating from one place to the other. Everything would be more transparent, because the services that will be provided by the containers will be available the same way they would be available on any platform. It's even possible to use the same container description and migrate this container description from a Power environment to an Intel environment, and from an Intel environment to a Power environment. So I've demonstrated this with MongoDB, where I do migrate a MongoDB database from a Power, then I go to Intel, and then back from the Intel to Power servers, just to show how containers can help on a movement that otherwise would probably be installing a lot of our RPMs, migrating the data from one place to the other. And while you do this with using containers and a platform that can help you to move data everywhere and make it available to containers as persistent volumes,
so you open invite to
that makes it very easy to create the hybrid cloud. So that's really the how of doing that.
And then you can keep all the events.
So just so we don't forget of why containers, they are agile for deployment and for development even. They are available and scalable. You have a cluster much like HPC. Kubernetes is a scheduler, and if you lose one node, that doesn't really matter a lot. You have all of the other nodes part of your cluster to take over for that workload for you. It is portable, like I said already. I won't use much of your time on that one. And it's manageable, because you can, since you have smaller parts of code and you can change the code of that service only instead of changing the whole application. That makes it easier and faster to recompile a single service and redeploy it on the application as a whole. And they are efficient because we don't need the underlying infrastructure of our operating system. All of the libraries having to be installed on each of the systems that we need. And really only what you need is already inside of the container to run. They are great, but if you just do containers, they start just sprawling because they are microservices, and an application can have hundreds of containers. So the idea is that we have to manage that. So the
Yeah.
use case of managing container is really important. For that, we use Kubernetes, and that's what it does. It organizes and govern the container chaos. That is, containers are really great, but after you start your application and you really try to silo your code into microservices, you get more and more of them. So with Kubernetes, we organize these containers and we can scale up and down um, the containers as much as you like. So for example, if we are talking about the learning platform that we just saw, uh, we can start small because people are still getting used to our learning platform. And then we start getting more and more people to use our learning platform. And that can become thousands and even millions people using the same platform. So you need to be able to scale that to the point where you can serve millions of people on the platform that you want. And one good example is an airline reservation on a sample application here that we have. This is one of the use case of containers and how to use them as services, as microservices for one application that would be the booking application itself. So all of this is part of the services that an application that is a booking application would need. But all of these services are independent and they will vary with the time, holiday schedules, also demand. So for example, now probably a lot of people are trying to adjust in the inventories across the world because of what is happening. So they would probably get this number of containers. So you can imagine that each one of these hexagons are containers. And this is the number of replicas that you have of that container serving your application. So you likely would have to give more resource to adjust inventory than really booking flights, right? Trying to update the customer and make them available to look the timetable and reallocate the seats of people that would be traveling, but now a flight got canceled or something like that, and you have to redo it. So this is how we would use it on a real application. In this case here, how it's being used. There is a American Airlines example on IBM using cloud, just so you can see. Here's the YouTube, and I believe the presentation will be shared with you too. So this is how it would be. The idea is nice of having everything organized. So if you want to have support on Kubernetes, you would have to choose for one of the distributions that are supported from the many vendors. Red Hat OpenShift is one of them. And it was thought to be an enterprise grade Kubernetes while still using open code and enabling people to do to use the platform to serve the end users better. So the whole layer of infrastructure gets virtualized on a layer of a runtime that is using Core OS today. Then an automation and a cockpit that you can manage your resources, the network, the storage, all of your images that you are using to enable the deployment. And all of this will be the orchestration of these resources by the Kubernetes layer. Then on top of that, OpenShift also aggregates help to customers to ease the lifecycle management of applications. Customers will just focus on the generation of code that in the end will be self-service to the end users that will be just accessing the containers. They don't really even get to know what a container is. They ask for the service. This could be even a Jupyter workbook, for example. And I don't know, or I don't want to know where my Jupyter notebook is running. If it's a container, if it's not, I just want to use it for my data analysis that I have here. So this could be one of the self-service applications that a university would provide to students, for example, for a big data class. It's today the most used application or Kubernetes distribution in the world. Now we joined with IBM, and we can give the solution end to end. So this is how you could provide a reliable experience to people creating your platform and providing end users the best of the container world without having to worry how to manage it. So if we go a little bit deeper on how we do the lifecycle management, the deploy automation and the build automation will even construct for you direct routes where as soon as you deploy your application and it's running, the customer can already access it through a name that is automatically generated and is already available. So that means an application can be instantly provisioned without any interaction with the underlying infrastructure. This is critical for a service, self-service portal that really works for anybody that wants a service created. And this goes back to what we are talking about. We are talking about exactly that. And making sure we have the applications on a portal that you can search, click, deploy, and have the experience that we were talking about on how to generate fast applications and fast deployments to end users that just want to use the application itself. And what if you could lower the TCO that normally, if you're going to public cloud, would be higher, like I said, if this is something that you want to provide to your users for an extended period of time, if you could maximize the virtual processors that you buy from your software environment, and could be flexible on-premise as you are on a cloud, and use any kind of infrastructure as a service, not being tied up with the infrastructure as a service that you have on that specific cloud. Also having a faster machine learning and even more containers per core with databases. So all of that with higher security and reliability. So using Power, you have probably the best underlying hypervisor, and there's no security vulnerabilities on that hypervisor for the last 3 years. The isolation of each of the VMs are really firmware-based hypervisor, and it was the #1 server for reliability in the world. So if you could do that with Power and OpenPOWER, you would probably choose that platform for it, and that's the case of it. We really have all of this, and the proof is in the pudding, right? This is a comparison that it was done some time ago on containers, and we do achieve a better container per core. This means less license that you have to pay, and you can see really on the license numbers that are really where you pay the most on these days. The software cost is normally something that you have to pay for, and if you want to do virtualization on Intel, for example, it's something that is not already there. So you would have or going to KVMs and open source codes, or you would have to go to something like VMware that also adds a lot of dollars on the top of the cost to it. While if you use something like Power L922 that has Power VM already there, it's already included with the hardware when you buy it, if you want to buy it with virtualization. So the idea is that you can run more containers per core on Power, especially because we have a higher number of threads, and Kubernetes really consumes is the threads of the processor. So whenever you ask for one CPU there, you're really asking for one thread of the CPU. That is the logical CPU that is seen on the Linux environment. And that's it. I don't know if you have any questions on how to use. If you want to see any a demonstration, I can create a demonstration for you and bring it on a next webinar that could be available for us. Ganesan,
Yeah.
go back to you.
Yeah, thank you, Daniel, for that detailed presentation about the OpenShift hybrid cloud. Thank you again, and I'd like to invite the panelists as well as the participants, for question and answers. Hello.
Hello.
Yeah, no, panelists,
Yeah,
Dharmesh and Professor Aswani. Any
yeah,
questions for Daniel?
yeah, sure. Hi, Daniel. This is Dharmesh from Tech Data. Very insightful presentation on the Red Hat OpenShift platform. Okay, and I think this last slide really took the cake, where you have clearly depicted how can we optimize more on IBM Power L92 922. Okay, with more efficiency and a better ROI and TCO as well. Okay. What I wanted to know was, two things. One is, like you did mention about, kind of giving a demo around this. Okay. So can the customers or maybe partners or participants access this demo through the IBM Labs, or do they necessarily have to go through you or Ganesan?
No, we Steer,
Part-
yeah, go ahead, Daniel. Sorry.
Yeah. So partners would likely have the access to the ECC center. I can give some ideas. So they can access OpenShift environments to do the demo themselves. I do have an environment myself that I can show in here, just so everybody can. I'm bringing it up.
Okay. Thanks, Daniel.
Yeah.
Yeah.
But,
My next.
yes, sir.
Sure, sure. Go ahead, Daniel.
I will share with Ganesan to send to the distribution list of the participants the how to have partners to access the demo. But you can always do OpenShift install on your own laptop. I will give that option too. And you can always come to me or Ganesan to make sure we present to you if you want to see a bigger Power environment. I just got my environment up, and since the question was about doing it, to show a little bit of a cluster. So this is my test cluster. I have, this is based on Power VM. It's a cluster, full Power cluster based on a Power VM environment. I have here about 128 gigabytes of memory and 5 terabytes of file system. The full operator hub that can or show everything that you have. On this environment that I have, I don't have anything, but it would be a catalog just like the one there. It's my test cluster at the moment, so I don't have a developer catalog here. But in here you would see just the search bar and all of the operators that you could install for your server. I can, like I said, I can get a demo with all of the look and feel on the environment and show to you, and you can always come to us to see a full POC demo. I might also be able to deploy one to Ganesan, and that could be available for people if they want to access that, and then we can see how to make that available for people to access and have a look and feel of the demo environment.
Thanks, Daniel. Thanks for that, and it would really be useful for, as you said, that you could help the participants or customers even kind of have a small platform or a demo on their laptop as well, install on their laptop as well. That would really be helpful. The next thing, when you mentioned about a hybrid cloud or maybe a multi-cloud environment, okay, so in India we have a lot of localized cloud providers. Okay, so is that the Red Hat OpenShift platform along with Kubernetes would only be restricted to the hyper cloud providers like maybe an Amazon or Azure, or can we also extend it to the local cloud service providers, which are many here in the Indian market?
Mm-hmm. So it is possible to install OpenShift as a bare metal install. If you have the possibility to boot, for example, even a DHCP on your cloud provider, you don't need the IPI environment to bring it up. So it is possible to run and get it up. You would need to provide probably just the support for your customers as a partner, for example, on top of that. So figuring how to install it and make it available using the method of installation without the APIs of a cloud, that would be possible too.
Okay, thanks, Daniel. And when you just mentioned about the installation, that was what my next question was going to be. Would IBM and Red Hat help the customer in setting up a Kubernetes solution with a hybrid cloud environment end to end?
Yes, so we do have services, but I would say that in that case, the services are normally around the bigger clouds environment for the public cloud and any data center for sure. We do have the people that would install with the customer, with the partners to install and try it on their own data center, or in that case the cloud, the hyper clouds like you mentioned. If the partner would be a small cloud, if the small cloud would like to partner with us and provide help to make it available to their customers, then I think that could be possible too. It's just question on how to operationalize that. I am helping some partners to build their own environment on their client centers. So that's something that I can also offer. If you do have a demo environment that you want to showcase the power, and also IBM storage, I can help. That's something that I could help people to provide.
Sure. Thanks, Daniel. My last question is, we all know that Kubernetes, containers, Red Hat, OpenShift, open source, these are all going to be the technologies that are going to be upcoming, and even the future ones as well. Okay. Outside, maybe, I mean, not from an India perspective, but what is the adoption that you are seeing, particularly in the education fraternity, okay, on the adoption of such platforms which are around Red Hat, OpenShift, or Kubernetes or containers? Okay, do you see it being largely adopted by the educational fraternity worldwide?
I've been seeing a lot of universities using it, especially on the part of the of research. I see a lot of it has been a difficult fight on the type of the container and the kind of container that scheduler that will be used. Now that we are going into open container definition by the OCI, we would have probably an easier way to use containers in a broader form that we have today, because today I see universities going with Singularity more than Kubernetes, to be fair. But slowly the new open container initiative is really bringing more people from universities, from the Singularity place that was mostly there, to Kubernetes and OpenShift by that, using the CRYO the scheduler instead of the Singularity.
Okay. Sure, Daniel. My question now to Ganeshan is, Ganeshan, like the way that we conduct workshops on Power AI and analytics, okay, is there a possibility of maybe conducting some workshops around Kubernetes and Red Hat OpenShift along with IBM platform?
I don't know, actually. I've never been in this position, so.
Ganeshan, I
Ah,
think you are on mute.
Yeah, I'm back. I sorry, there was some network issue. Thanks, Daniel, for all your answers, to Tech Data's question. Thanks, Dharmesh. Professor Aswani, do you have any questions from your side?
Yeah.
Please go ahead.
Daniel, thank you very much for the wonderful presentation. In fact, your illustration on the containers and the VMs and all, it's very informative. First of all, from the academic perspective, I have a couple of questions. One is that it would have been interesting, if how the concepts of the cloud computing and the virtualization can be introduced to the students as an academic faculty. If any kind of resources are there, starting from like simple examples, how we can introduce the concepts. Are there any some tips or the examples?
Yes, so there are nice examples of microservices that can be used. There is a virtual shop. They show how it would be a virtual shop containerized. I can get the GitHub for that. So can distribute that. I will start looking on everything I would like to send to you. But yes, this would be probably the best way of starting it. So it introduced the concepts of service mesh and how microservices will talk to each other, why this is better for development than the monolithic approach. And I think it's a good base for a ludic, like, to make sure people will get the most of the understanding on how and why to use containers instead of a single monolithic application. I'll send that to Vanessa as a link for that too.
Yeah, so on the same line, if a faculty of teaching the course on the cloud computing, and is this possible to offer a lab in the form of virtual mode, like a virtual lab with this setup?
It is possible to do that. I need to search for equipment to make that available, because I'm not on a lab or client center position at the moment. Like I am a pre-sale, but I can try to work with people to at least try to get some hardware that would be available for you to create. I would be willing to create that for sure. I would be willing to help on creating something like that, because I have interest on the topic of that.
Yeah. So in the similar the question what Dharmesh has also asked, if both IBM and Red Hat can hands-on session, even on a virtual mode, like this kind of a webinar mode, wherein which the academic faculty would be really interested to participate to enhance their understanding. That would be really interesting to see. Yeah.
It's a good feedback. Thank you. I'll probably work on that, like on how to show the difference. And okay. Great.
Yeah. Okay. Thank you. Thank you, Professor Asfani. As a panelist, definitely, I appreciate your time and effort. And thanks, Daniel, for the detailed presentation.
Daniel,
again.
I have a question for this OpenShift. And do we have time, Ganesan?
Yeah, go ahead, please. One more
Okay.
question. Yeah.
Yeah, sure. Daniel, I mean, what is your view about this singularity and OpenShift? I mean, because in the academic domain, we are mostly using this singularity in all the HPC server and everywhere. Singularity is there. So, considering Power 9, which one should be the best choice and why?
So I do see the best choice being Kubernetes in the end.
Okay.
Like OpenShift is probably the best one because it would be supported end to end, the best Kubernetes. And I'm saying that because even Singularity is going OCI, the open container foundation. So whenever we get there, all of the images will be the same. Now we do have the special registers to access memory. Like that was a fault with Kubernetes, and now with CRI-O we are getting a better approach on that. Also, the other problem with Docker, that's probably why people went to Singularity instead of Kubernetes, because Docker was was really used with Kubernetes until OpenShift.
Yes.
The CRI-O stack is as small as the Singularity stack, so you don't have the overhead that people were worried about on Docker. That's why I think just because of a consolidation point of view, Kubernetes is the best. From a support point of view, if you use Kubernetes OpenShift, you get the CRI-O environment that will make it better for HPC than Docker. And you get the support for a Kubernetes that is widely spread across industry. So the academia will not be alone. That's why I think that's the case.
Okay, great. Thanks for the excellent explanation. And also, I mean, I just wanted to let you know that I am also developing a course on, I mean, for the online platform that I have just presented. For that, I am developing a course on virtualization and containerization. So I may need to get back to you with a couple of questions at some point of time.
Oh, that's fine. I'm available for that.
Thanks.
Yeah.
Thank you.
Yeah. Again, thank you, Professor Arghya, for the wonderful questions, and thank you, Daniel, for the presentation. And I'd like to thank presenters for the presentations today. Thanks to panelists as well as the participants for all kindness and efforts to participate in this webinar from OpenPOWER Power 9 Academia team. Looking forward to meet you all on June 5th webinar with the Berkeley Lab and IBM. And thanks again. And now I'm closing the webinar now. Thank you.
Thank you. Thanks, Ganeshan.
Thank you.